Hello! You're in for a treat.
Tuesdays and Wednesdays and Thursdays.
2 West.
6 to 7:30 p.m. Eastern Time.
We got new hours because we're nerdish.
And we're in our 20s despite our looks, so we gotta do things in the evening time over the summer.
Correct, but not too late because, as Levi said, we're in our mid-20s.
Not our early 20s.
And not our late 20s, the mid-20s.
Yes, we're the Goldilocks of 20s.
That's right, I shouldn't have laughed. I gotta keep it cool, because this is our intro rap, where we keep things cool.
We're very cool, so cool we might want a dance break.
Hey, thanks for watching our dance break.
Now, back to the really serious stuff.
Like Brady
And Levi.
and Brady too. We're the 3 members of the Nerdish crew.
That was perfect. We didn't plan that.
Not at all. We don't plan anything. If you couldn't tell by this rap. That was the one thing we rhymed.
That was the one thing.
Which makes it a rap.
Yes, all raps have one rhyme.
We'll see you on 2 West.
Yes, 2 West
6, 7:30 p.m.
Eastern Standard Time.
Keep watching, because it'll turn into us, but probably not wearing the wigs.
Yes, and we'll be much more responsive to whatever you have to say.
You could ask us questions right now. We will not answer them.
Also, we take no responsibility for anything we've done in this pre-recorded session.
Yes. Any lost items, Nerdish is not responsible.
Right, we don't have anything to do with it. We're very different people in the present than we are from when we're recording this video. You might say we are the pupae of Nerdish right now, and in the future we will be the moths.
The
Because moths are the
disgusting
most-
gray moths.
Yes, those gray moths that you hear, they're
Yeah.
like the bats of the flying community.
The wings are leathery. They're leathery wings.
Very leathery.
They're basically butterflies, but we hate them.
Yes.
They're the rodents of butterflies.
This is true.
Right?
Just like the ACT is the rodent of the SAT.
I don't agree with that. I don't agree with that at all.
Future.
Oh, very good. Oh, nope.
Oh, jeez.
Good evening to those of you who are here. Good evening for those of you who are here. And then 2. Anyway,
Maybe.
we're gonna do some questions.
I'm gonna tell everyone on the Discord that we're here.
Do it. You and me. Oh no, I shouldn't say that.
but.
Wait, is this
Right.
what we want today? Yes, no, that's yesterday.
We did that yesterday.
We did? Okay. Brady posted.
Me?
Yo.
Yeah, I did. Keep talking.
We got a general SAT. Oh, look at that. I tried to, Willie posted in general, I tried taking one of the practice tests slow like you guys suggested, and I ended up with a way better score than I usually do. And it ended up barely going over the time limit, which is really weird. Maybe it's just the stress of worrying about time that's messing me up.
Probably is.
I'll wait for Willie to be here and then we'll say hi. So, Willie, Cookie, if you're here, say hi and we can talk about that.
Cookie God. Cookie God.
The good of the
Cookie.
Let's see, maybe there's some SAT questions we can do.
I'd like that. I'd like that a lot.
I bet you would. Well, that's not helpful. Nope, that's not helpful.
That's not helpful either.
Yesterday.
What do you guys want to know?
Yesterday.
We have all the answers
All
that we
my
have.
troubles seem so far away. Yada 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 yada
It looks as if they hate us die.
Here to stay.
I believe.
Yesterday. Yesterday.
I heard a comedian with a pretty funny joke. Were you there?
Was it the comedian from last week?
It was Australian. No, he told an
I
Australian
thought you were making a joke about Dan Segura.
No,
Or
no,
Tom
no,
Segura
Tom
because
Segura,
you
no.
invited me and then didn't.
Yeah, that's right. No, he was saying it was this funny joke about an Australian. It's an Australian guy that. Oh, jeez. Hold on a second.
Yeah, okay, so this Australian guy comes to the United States for an extended visit, and he is not used to driving on the wrong side of the street from his perspective.
Hi, Kuzi.
So one day he forgot that we drive on the right side, as in the correct side, and he's driving up the left side, and then he sees this truck coming, and he barely gets out of the way right before it goes past him. The truck screeches on the brakes, and the guy came out, and he's like, you know, what the heck? He's like, sorry, I just came here from Australia. Well, he said, I just came here from Australia. The guy said, did you come here to die? And he said, no, I came here yesterday.
Very nice.
Yeah.
I like it.
I liked it too.
Can you explain it to me?
No.
Kuz, how are you? What's going on?
Why did they say anything?
Well, Kuz posted, so that's, as helpful.
Well, I want them to
The
say
polynomial function f is defined as f of c,
Good.
and that equals this thing, where k is a constant. Okay, let's just stop at that first line. It says f of c. That's the same thing as f of x.
Yeah, can we just make it f of x?
I like being able to deal with f of c as it is. But yes, you could make it f of x.
This is remainder theorem.
Oh, is it? Yes, this is straight up remainder theorem. This is weirdly specific, I think, for the SAT. This is one of those things where you know what they're asking about, or you're not going to get the question right. It's one of those.
Yeah.
So do you want to write up the rule for remainder theorem?
Sure.
This is just a thing you need to know. I'm going to rewrite the original function.
Okay. Let's not say anything while we're doing this.
Yes.
Yeah.
Oh, actually, that's kind of cool.
What? That's kind of cool.
That this function, if you actually, so I'm going to factor this, by the way. I have no idea what that is. Exactly. That's why Bird is going to explain it. But there's this other thing. So we have c minus k. Let's factor this thing. We get c minus k times c minus 2 squared, right? And then we're asked, what is the remainder of f of c when it's divided by c minus 2? Well, if you divide by c minus 2, you're going to get, let's divide by c minus 2. Should we just do remainder theorem first and then talk about it this way?
I feel like it'd be easier to do that.
Okay.
Yeah.
So
Okay.
you want to explain that to him?
Sure. So now, Kuzi, if you take a polynomial and divide it by a linear factor, x minus r, you're going to get some other polynomial, and you're going to get a remainder over that number. So just to...
x minus r again, just like what that is.
About what?
X minus r, how that's a linear factor, what that means.
Yeah, okay. So like if you're going to take... like dividing something by x minus 5. So let's say we have like x cubed minus 5x squared plus 6, and we're dividing it by x minus 5. This is a factor. It's a linear factor. Linear because it's degree 1. You got a polynomial, and it's only x to the first power. That's a degree 1, and degree 1 lines are linear. Degree 2 gives you quadratic parabolas. Degree 3 gives you cubicas. That's not a word, but that's why we call these linear factors, because there's a little linear degree 1 situations. So if you divide something by something, like 17 over 10, you're going to get 1 plus a remainder of 7/10. All right, 1.7. But the fact of the matter is, you're going to get the largest whole number you can get, and then a remainder over what you originally divided by. That's what's going on here. You have a polynomial, you divide by some linear factor, that will get you a smaller polynomial plus a remainder over what you originally divided by. That's how it starts. So where the remainder theorem goes, it goes some pretty neat places, but the first thing you'd want to do is if you multiply both sides by x minus r, some fun stuff is going to happen. So I'm going to multiply this by x minus r. I'm going to multiply this whole thing by x minus r. So that's going to cancel out the bottom. The bottom.
The bottom.
The bottom. Leaving us just px of x. Here we have q of x, but now it's going to be multiplied by x minus r. I should put this in parentheses. And then the x minus r times this term will get rid of the denominator, so it's just going to give us here. R stands for the remainder. Okay, that is the next step. Let me know if you have any questions on that. You'll be like, what's the point of this? You'll see in just a sec. Then we place r, lowercase r, in for all of these, for all the x values you see. So if we take p of lowercase r, that's our new input. We need to put that in for all of these things. That's going to be q of r, equals. I'm such a bozo sometimes.
Yeah.
X here is now going to be r, which is important. You'll see why in a sec. You can probably already see it, plus the remainder. Okay? Hey, it's Slayer Darth with his typical polite hello. Hello, Slayer Darth. It's going well. What about Brady? Yeah, there we go. Thanks. R minus r is 0. So this is going to be q of r times 0 plus the remainder equals p of r. And this right here, because it's being multiplied by 0, goes away. So we are left with p of r is equal to the remainder. So let's start back at the beginning and see what this means. You have a polynomial, you divide it by x minus r. You want to find the remainder. All you have to do is plug this value in, little case or lowercase, oh my god, little case. Lowercase r, you plug that into the original polynomial, that will be equal to your remainder right off the bat, okay? You don't need to remember how to prove this thing if you just remember this. You want to find a remainder from polynomial long division without having to do polynomial long division or synthetic division? Synthetic division is not that bad, but in this case we only have constants and letters, so we're not going to really get that far with that. We want to do this. So we have this polynomial. The value 2 is a 0 of f. That's kind of fun. So if we're going to take f of c, let's see, if it's a 0, that means it's factorable by that. Oh, Levi.
Yeah.
Does that mean the remainder is going to be... Okay.
Well, so
use my... Okay, yeah, you got it.
Use the remainder theorem.
Yes. Okay, so f of c, we want to get the remainder when that's divided by c minus 2. So according to the remainder theorem, we're just going to put our r value, lowercase r, into the function, which is going to be f of 2. So I'm not going to set that equal to because it's not. F of 2 would mean we'd plug in 2 for all the c values. And if we do that, we get 2 minus k times 2 squared minus 4 times 2 plus 4. And lo and behold, if you do this, you're going to have 4 minus 8 plus 4. That's going to turn into a 0. Doesn't matter what your k value is. F of 2 is going to become a big fat 0, which means the remainder is 0. Now actually, we sort of could have guessed that from the beginning, because if 2 is a 0 of f, that means that one of the factors of f is c minus 2.
Ding, ding, ding.
That must be a factor of f. That's the only way that 2 ends up being a 0, because of the connection between factors, roots, intercepts, zeros, and solutions. Not Kuzi, do you know the connection between factors, roots, intercepts, zeros, and solutions? If not, we will go over them.
Is it 3, my lord?
Yes, the answer is 3. That's the connection between all those things.
3.
Ringo. Aren't they all the same? Yes, with the exception that they're the kind of the opposite number of this. So this is your factor, which means your 0, root, solution, and x-intercept are all going to be positive 2. So that means it's divisible by c minus 2. And if something's divisible by something, that means it's not going to have a remainder. So 20 is divisible by 10. You get 2 and no change whatsoever. So the answer is 0. That is your remainder here.
Yeah. You don't have to know how to derive the remainder.
It's so
theorem.
elegant, though.
It is a beautifully elegant solution.
Elegant.com.
Today.
When we have this type of problem, just plug in the 0 or whatever number. Yeah, if it's asking for the remainder when it's divided by something, yes.
Yeah, don't plug in 0. In this case, we didn't plug in 0. We plugged in 2.
Oh, he said plug in the 0.
Don't do that either.
Well, we only know that c minus 2 is a 0. They don't. This is kind of a little gimme. If you're aware of what zeros mean, you know that they connect to factors. And if something's a factor, So it's only if they're asking what is the remainder when this polynomial is divided by x minus something or x plus something. That's when you're going to throw it in. It looks like I have horns.
Yeah, so, I mean, I'll just give you one more example. F of x equals x squared minus 2x plus 4. And if we are asked what is the remainder of this when we divide it by, what is f of x divided by x minus 3? You just take 3, you plug it in. So this will be equal to f of 3.
Well, the remainder will be equal to that.
The remainder of this. So remainder, this is stupid. It's a poor way of doing it. The remainder of this, when you divide by this linear factor, you just take the number here and you just do f of that thing.
Slayer Darth, I also was not taught this in school. So that would be f of 3 divided by x minus 3. No. The remainder would just be f of 3.
Yeah.
I think he
This is stupid.
interpreted that equal sign.
That was very wrong. So when you're trying to find the remainder, just like they say up here, they say what is the remainder of f of c when it's divided by c minus 2? All you do is this is all you do. F of 2. You solve for f of 2, that will be the answer to this question.
Yeah. This only gets you the remainder. It doesn't give you the quotient. If they say, do this, perform this polynomial long division, then you're going to get a quotient and a remainder. That's a whole thing. This question is just asking, what is just the remainder? We don't care about the quotient. We don't care about this part, what you're actually going to get. We literally could not care less about the quotient. We actively are apathetic to the quotient. Why does our restream say 0? People are watching.
Yeah, they're probably watching.
Hey, can you go over synthetic division?
Your friend Spam Risk is calling.
Oh, it's.
I remember when you met Spam.
Spam risk. Can you go over synthetic division because I hate polynomial? Yes, I would love to go over synthetic division. So r over x minus r is irrelevant. Well, it becomes irrelevant because I multiply both sides by x minus r. That's how we get to this part right here. So we started with just the general form of dividing by a linear factor, which gets you a quotient and a remainder over that factor.
Hey Siri.
And then, no, please don't. And then you multiply both sides by x minus r. Yes, all you need to remember is that. Correct. Oh, jeez. What is going on? Oh, what did she say? Okay. So we're going to talk about synthetic division. Synthetic.
Why don't you start? I'll start erasing for you.
Thank you.
I don't like synthetic division.
Why?
I've explained this to you.
No. Here's the thing. You'd explain it. Yes, it's only applicable when you divide by a linear factor.
Yes.
On all of these tests, that's all they make you divide by. It's only ever been linear factors on these tests.
It's not true, my lord.
Have you found questions where they ask you to divide by a degree of greater
Yes,
than
my
1?
lord.
Find one. Find one for me and I'll believe you.
I found it, my lord.
Where?
Right there, my lord.
Well, that's... dude, we wrote that!
It would.
And there's still nothing that we're dividing by that's not a linear factor.
Why not 3, my lord?
In the U.S., do students that sit at different papers based on their academic leader, they sit in the same papers. Sit the same papers is not exactly... I'm not really sure what you mean by that. You mean like take different tests or what? But I remember some SAT guy that r divided by x minus r is important. Well, I think he was referencing the remainder theorem, and that is the thing that you need to remember. But we will talk now about synthetic long division.
Kuzi, we are your
synthetic
SAT
division.
tutors. Nobody else.
Nobody else.
If you actually call your SAT tutor that you're talking about right now, no pickup.
Yep.
Nobody's on the other line.
Nobody's right. As do they have higher and foundation tiers. Still not exactly sure. Are you talking about like in high school? Or are you talking about in college?
What are you talking about?
Slayer Darth, you speak a different English than we do.
Yeah.
We don't know what that means.
We don't know.
We just don't know.
We don't get it.
You need to explain.
Yeah, you have to.
If you keep this from us, we'll be angry.
We'll kill you.
Whoa!
What?
Levi.
I didn't. It's different in British. What that means?
In high school, yes. Okay.
So
You said,
I mean,
what?
and
You place into different tiers. Yeah, kind of. Like you do have a progression of classes that have different levels. So like they give you a math placement test some year of junior high or high school, and that determines what math class you should start out in. So some kids start out at, Algebra 2. Usually that you take that in like 6th grade, and that kind of starts you off.
The very smartest kids we send to Britain.
That's right. They all get sent to Britain. But yes, you have some kids taking high-level honors pre-calc while other kids are taking Algebra 1, and they're the same age. As in, if a student does not perform well in their math classes where they sit a different maths paper, okay, so sit a different paper, I'm not sure what that means. I think that's the hard part here.
Maybe final exams.
By different math. Yeah, what do you mean by different maths paper? Yeah, different final exam? Think about how British that sounds. Sit a different maths paper.
That's very different.
That's
the
so
prepositions
British.
there.
Yes. I'll sit a maths paper. You talking about a different SAT test? I'm not sure. Slayer Darth will answer. He always does.
He always does.
Ooh. Ooh. All right. Let's say we wanted to perform this division. Polynomial division. Synthetic is the fastest way to do this if the denominator is linear. X minus 8, x plus 5, just first degree. Okay? This is how you do this. You take the number you're subtracting by, 8. You're going to put that, bam, right here. Draw yourself a little fun shape like this, okay? So in general, you got something, and that's over x minus r. This is the number you put right here. So if you have like x plus 5, you put negative 5 here because it is the opposite of what you think it's going to be, okay? Then you're going to write all of your coefficients, but just the numbers themselves, in a line right here. First one we have is 5. Then we have 6, negative 2, and then 8. Great, we're doing really, really well. The first coefficient, you drop directly down with this little arrow, 5. Okay? Now is when the fun starts. You're going to multiply this by this. Wait a second, I've done this a million times. It's multiplying then adding, multiplying then adding. So bring that down. Okay. Yes, you're going to multiply this by this, which is going to get you 40. You put that here. As in, students the exact same. Yes, they do. They take the exact same one. Yeah, the only difference is you could apply for accommodations, which are like extended time, if you have like ADHD and some other stuff. So that is what differentiates some students, and they might get time and a half or double time, but it's all the same test. Yes. So you multiply these two, and you put the product right here, and then you add. 6 plus 40 gives you 46. Then you multiply again. So 46 times 8, which is going to give you 320 plus 48, which is 368. So you multiply these two, put it right here. Then you're going to add these, which is going to give you an even smaller, an even larger number. It says 366. Over here, at least for the maths exams, we have foundation and higher tiers. So if you're a low-performing math student in the school, generally recommend that you take foundation tiers papers. But then the colleges know that. They know that you're taking that lower level papers, I assume. And then okay, so wow, this is going to be not fun at all. This times this, which is going to be 2,400 plus 480 plus 48. So that's going to be 8, 12, 9, 2, 29, 28. Then you add these last ones. Ugh. I will check this, by the way, don't worry. Add these last ones, you get 29, 36. Okay. These numbers down here represent the coefficients of your quotient, with the exception of this very last number. That right there is your remainder. So what we have here is 366 is the coefficient. It's not even the coefficient, it's just the constant. This is the x, this is the x squared. We have 5x squared plus 46x plus 366. I'm going to do a much easier one in a second because these numbers did not do that well at all. Yeah, exactly. You're not able to earn top marks. That makes sense. That makes sense. If I were to do this with polynomial long division, I just want to make sure this is going to get... Yeah, it's going to get super out of hand. That makes sense. All right, easier one then. Easier one. Remember that last number on the bottom is your remainder. So like you had a cubic, and yes, exactly. You had a cubic and you divided by linear. So if you just make that really simplified, you've got 5x cubed on the top divided by x on the bottom. If you simplify that, that'll get you 5x squared. So your answer will be a quadratic because you've divided a degree 3 by degree 1, and you subtract exponents, so you will get a quadratic there. Fatality. Fatality, you've not lived up to your namesake and not lived. That's good to hear. High fat. Fate, because it's fatality. Much easier one coming down the pipeline. X squared minus 8x plus 16. And we're going to divide that by x minus 3, which means if we do that, we're going to set it up over here like this. 3, bam, bam. 1, negative 8, 16. Send the 1 down right here. Multiply gives you 3. Add it gives you negative 5. Multiply gives you negative 15. Add it gives you positive 1. That's your remainder. So your answer here is x minus 5 plus the remainder of 1. That was way easier. Oh my gosh. Oh my gosh. It's minus 3, so we just take the 3, we put it right there. All right? All right, all right. So you put that thing down first and foremost. Another thing to remember, you cannot use this. And this is partially to Levi's point. So x plus 5 plus 1 divided by x minus 3. Yes. Except your parentheses need to be around x minus 3. Because right now it looks like it's 1 divided by x minus 3. But it's 1 divided by x minus 3. But yes, that is right. That is going to be the quotient. If you have a leading coefficient here that's not 1, you can't do synthetic. You've got to do polynomial long division. Yeah, there you go, Nakuzi. I'm going to do one more, and then we will move on. What happened with Cookie God? Cookie God had to return to the cookie heavens, where he/she reigns supreme as lead cookie. Oh, hi. Oh, Cookie's here. Very good. Now, just to show you something you have to be on the lookout for. X cubed plus 7 divided by x plus 5. Okay? Two things. He, she, it. I, wumbo. You, wumbo. He, she, wumbo. Where is Levi? Levi.
Yeah.
Levi. He's over here. Don't worry. I haven't killed him yet. If I'm going to write this out with polynomial long division, I take that back, synthetic. This is going to be a negative 5. We have a 1, but we don't go to a 7 yet. We have a bunch of terms in here that do not have coefficients. We have a 0x squared. We have a 0x. We cannot forget about all the degrees until we get to the constant at the very end. So we have 1x cubed plus 0x squared plus 0x plus 7. Don't forget that. Stop on your right foot. Don't forget it. Multiply. Then add. Jeez. Multiply. Then add. Multiply. Then add. Remainder. X squared minus 5x plus 25. Plus a little remainder of negative 118 over x plus 5. That right there is your quotient. According to synthetic division. It's not natural, it's synthetic. Do not put it in your body. It's not healthy. Thank you. No scope battlefield. All right, bye. Got to go. Don't go. Stay here with us. We need you. I need you.
No scope battlefield.
Not Kuzi. I don't know, but they don't need a scope of the battlefield apparently. Not coups. Is this cool? Can I erase this? Do you want Levi to show you polynomial along division, or do you have that down?
I want to talk to Cookie.
Okay.
Cookie, what you put in the Discord is awesome. So yes, it's not a fluke that happened. Prod, what's up? It's not a fluke that happened. So just so those of you who don't know, if you make simple mistakes, try taking more time on a test, and do a practice section or two without timing, or you can time yourself, but don't worry about the time. Don't rush, and focus on accuracy. Like, just practice being perfect first before you practice finishing in time. It shows you that you don't actually have to rush as much as you might be rushing. There's no point in rushing if you do finish with too much time left. And there is a line. I mean, of course, you need to finish or get close, but you got to find that balancing point between going quickly and being accurate. So, Cookie, the fact that you did way better is awesome. And now all you need to do is keep that level of focus. And I think that's what most of it is. Because I agree with you. You probably were stressing about getting questions done, so you skimmed the question. You cannot skim questions. You can maybe skim passages, but you cannot skim questions ever. It will not help you. You will be caught by whatever. Sorry, whatever.
Do you condone violence?
No, I don't.
Okay.
I didn't know that was your stomach. I thought that was your ankle that I hit there.
That doesn't make any sense.
Okay.
Oh.
Thank you, Prod. Yeah, I worry about time a lot, and it stresses me out. Yeah, so with that, Bird, what do we do when we get stressed?
Whenever Levi and I get stressed, we have a two-part strategy consisting of repress and dissociate.
Do that, focus on each question, be methodical about it, and work on accuracy first as you practice, then start speeding up, but keeping that same level of focus.
Oh,
For those of you who make too many simple mistakes, that is the way to deal with them. It is not about just practicing, because then you're practicing making simple mistakes. You have to practice not doing it, which sounds sort of tautological and stupid, but it actually helps a lot.
We have literally so many questions.
Yeah. Hey, can you, for any of you who posted pictures that are not the right orientation, can you put those in the right orientation? It would help us so we don't have to do so much work on our end.
We'll do one of
Because
your.
it's so difficult.
We'll do one of yours right now that's not sideways.
Who is this, Cookie?
Yeah.
This is fun.
Isn't this fun?
I don't know.
Well, I think it's fun.
I think all of this is kind of fun.
Really?
Adderall, baby. Yes. Turn to drugs.
Especially if you don't know how they'll react with your system.
Yes.
Use them on the day of the test.
Take them all at once.
Jesus.
Right, Bird?
No.
Oh.
That sounds very, very dark. Hey, enjoy this, Mr. Dark, man.
Thanks. Thanks for making it full screen, by the way. Hey, Siri. Hey, Siri. You mad at me, Bird?
You didn't get it.
I know. Are you? Good job, you two. All right. The graph of the function f is right there. Lovely. And it looks, and that's the equation of it. Lovely. Is shown, yeah. If the function g, which is not shown, is defined as this thing down here, what is one possible value of a? Yeah, a, such that f of a equals g of a. Oh, okay. So we're looking for f of a equals g of a. Well, what is f of a? You two, stop bickering, okay? F of a, what is that? What is f of 2? What is f of 4? You plug in what's in the parentheses there for that value of x in the equation. So f of a equals 1/2, is that negative 1/2? Yeah. Negative 1/2 times a minus 4 squared plus 10 equals, and now it's got to equal g of a. Well, what is g of a? We do the same thing. We plug in a for x. Yeah, I'm going to separate you two. Don't make me separate you two. We get negative x plus 10. So this would be negative a plus 10. And this is our equation. Let's get rid of this thing. So we went from f of a equals g of a to now the actual equations. We plugged in a for the x's, okay? And now we're going to solve for a. How do we solve for a? Well, we're going to have to factor, I assume. So first I want to, there's no particularly nice way of doing it. You could also graph these functions if, I don't know what section this is on. What number is this? This looks like a calculator section question, so you could graph these and then find the intersection point. That's valid. We do have negative x. Oh, you can also, just graph it up there and you can see where it goes through. So that's useful. Yeah, but you think it's wrong. Okay, maybe the graph is wrong. That's fine. Let's do it algebraically and see how it goes. So I'm going to square this stuff so I get negative 1/2 a squared minus plus 4a plus 16 minus 8 plus 10 equals negative a plus 10. So the 10's go away. And then we get negative 1/2 a squared plus 5a minus 8 equals 0. So let's double both sides, or let's multiply everything by negative 2. Multiply this by negative 2, not that that matters. And we get a squared minus 10a plus 16 equals 0. Let's see, can we factor this? 4 and 4, 8 and 2 looks like a winner. So we get a minus 8 times a minus 2 equals 0. So 2 and 8 are where the x values would be 2 and 8. What is one possible value of a? So a can equal 8, a can equal 2. Tindo, hi, what's up? It is correct. Oh, I mean, no. Because the x scale is 2. Oh, it's a scaling thing. Yes, okay. They do that sometimes. This is actually a very misleading one, but yes, you gotta pay attention to your scale. Cookie God, you doofus. That's fine. That's a simple mistake, but they will do that on the test, so you do have to keep an eye out for it. So it's just like recognizing anything else. When you are ever looking at a graph on the SAT, or on the ACT for that matter, make sure you're paying attention to the scales of your axes. That will come up, most likely. I've seen that on many a test. Maybe not most likely. I would say 50% of the time you'll get a question on, you just have to pay attention to the scales, make sure you're bottoming it out at 0 on the origin. Maybe it won't actually be there. Can you talk about sector, area of sector, radian, degree, all of those things? Yeah, let's do that. Let's do that. Ratios. That kind of looks like a clock, but ratio, sector stuff. Yeah, we can do that. But I think we have some questions to get to in the Discord first. We won't do all of them, but we'll jump around. So that's a Tindo question coming up. So we just did, that was a Willy question. We've done a Kuz question. Oh, you deleted your second one, Kuz. Okay, that's cool. Who's in the Discord? What's your name in chat? Okay. Oh, this looks fun. Maybe. Who's Prod. Oh, that's Prod. Okay. Fun. It's always fun. Hey, Bird.
Yes.
You're up.
No.
Yes, you are.
I like that.
Oh no, we need much more than that. All right. Bird, get your butt over here.
You gonna say tuchus?
I was gonna say tush, actually.
Tush.
Hey, you know that town with the trains in New Jersey near New York City? You know what it's called? Secaucus.
No, it's not.
Yes, it is.
That's not true, Levi.
Okay.
Oh my gosh.
Are you set up too fast again?
Why does that only happen here?
Because
What is it about down here?
It's dark.
Is there like a... Is that where it is? Are we just inhaling carbon monoxide?
ideally.
You're right, that is ideal.
Yeah.
So I ordered this thing from Home Chef because I still had credit with them. They send you boxed ingredients to make meals. It's
That's
pretty-
a new idea.
Yeah. Anyway, I forgot to update my address, so it got sent to my address in Chicago, and so there's a box of ingredients with like frozen meat in it right now on someone's doorstep in Chicago. And I
Wait.
was really looking forward to coming here.
Oh, so you had it when you lived in Chicago, and then once you moved,
I stopped
you
getting it.
you stopped getting it, but now you started again.
Well, I realized that I still had enough credit for one more order. So I'm like, oh, this is fun. And so I ordered it.
That's a
It was
bummer.
going to come tomorrow, and I was excited. It was like some kind of like interesting delicacy tacos. Wait, did y'all start this already?
Start what?
This?
No, did
No.
you?
Did you?
Prod?
Vanix?
We're very proud of you, Vanix.
Let's go. Let's do it. I'm Wa.
Probably not.
We're also Wa. Okay. Wang Shu, which, okay. Wang Shu, probably. I don't know the tones, though. Measure the brightness of a glow stick. The equation below models the brightness, L, in lumens, H hours after activating the glow stick. Glow stick activated.
Glow stick in disguise.
Nice. Which equation best highlights the number of hours it would take for Wang Shu's glow stick, to lose 90% of its brightness? I'm Wa. Hello, it's boom time. I've heard that
Boom
it's
time, what's up?
boom time. That's
Do you
excellent.
want me to show you the answers here?
No.
Are you sure?
Yeah, I don't want it yet.
Hi.
I don't want it yet. Okay. How many hours would it take for it to lose 90% of its brightness? Let's interpret this equation right now. Okay? This is exponential form. So we have L is equal to, let's put it down here, 4 times 0.73 to the H. L is the brightness, H is the number of hours it's been. Exponential tells us that this number here, the starting number, is the starting amount before it starts either increasing or decreasing. Because at time equals 0, H is 0, 0.73 to the 0 is just 1, anything to the 0 is 1, so that's why we just have 4. We try to block this, but it only blocks it from our own view. It just 4, all right? I took a PSAT and I got 1140, improved by 100 points. My goal is 1200. Keep going, you're only 60 points away. I don't know if you've calculated that yet, but you're quite close. So 4 is where you start. 0.73 is the percentage you're taking of your starting amount every hour. So every hour, you decrease to 0.73 of where you were before, which is another way of thinking it is that you decrease by 27% every hour. You go down by 27%. Okay? So we want to figure out how long it would take for Wang Shu's glow stick to lose 90% of its brightness. That means that all that's left is 10%. If you lose 90% of your brightness, all that you have left is 10%. So if you start with if you start with 4, that's your starting amount. If you lose 90%, you're going to be down to 10% of that. 10% of 4 is 0.4. So 0.4 is where we want to get to, and we want to figure out what our H value is going to be that would get us to 0.4. I will now look at the answers and see how far they went with this. How far did they go? Okay, and they did something else. Good thing I didn't look at the answers.
Yeah.
You knew. Okay. So, okay, I have to look at all these answers.
Your feet smell terrible.
That's not true.
Yes, it is.
Dude, that's literally not true. How do you even know?
Because I smelled them.
I don't smell them.
That doesn't matter.
I don't know about that. Okay, so if we look at these answers here, best highlights the number of hours it would take.
the green answer, my lord.
Well, we'll see about that. So, okay. Keyword being best highlights the number of hours it would take. Highlights means it literally shows it to you. It brings it up in the equation. So we need to figure out what that is, because apparently they want to actually see that number of hours in the equation. So let's just find that first. I'm going to make this small again. If I want to solve this thing, I'm going to divide both sides by 4. I'm going to get 0.4 over 4 is equal to 0.73 to the h power. Okay? 0.4 over 4 is 1/10. That seems to make sense because we lost 90%. We're left with 1/10. So 1/10 is equal to 0.73 to the h. We're trying to solve for an exponent. It's up there. We don't want it up there. We have to take it. We have to rip it apart from its base. The only way to do that is to call my friend logarithm. All right, take a log. Logarithms will split this up. You're going to get log of 0.73 to the 1/10, not to the 1/10, but of 1/10, will give you h. And now it's time for a little calculator action. Gotta let this thing start up because it's powered by gasoline. And the batteries are even dead, so that's also kind of fun. There must always be a Stark at Winterfell. There must always be a nerdish guy on screen, and we just let that not happen. Okay, log time. Log time. Log time. Put on your log time. Log is a big number. 0.1. Log is -1 divided by 0.73. Log is equal to that. H, jeez, is equal to 7.317. So we have to find that number in our answers to show that it takes that many hours to get to 90%, to decrease by 90%. That needs to be in our answer. So let's look at what we have here. So D does definitely does not have that. The rest of them do have, well, 0.73 is not what we got. We got 7.3. So A and B both have 0.73, which means they're out. C is the only one that has 7.3 itself in there. USC, what S enough? What's enough? Yeah, I don't really know the stats for USC, but they're publicly available on the internet. So C is the only one that has the correct number of hours, which is 7.3 in the formula. Using calculator? Yes. Oh yeah, I took log base 0.73 of 1/10. Yeah, you got to use calculator. Human brains don't do that. But that is the number of hours it's going to take to get us down to 10% of our original brightness. And it has to feature that number of hours. That's what it's got to do. I feel like it's not great for a performer / presenter to be yawning all the time.
Nah.
Probably not, right? Excellent. Excellent. So that was a what question?
Prob, yeah.
So we're going to go back now to Willie.
No, let's do
Knit?
a knit question, and then we'll get to the Tindo question. No, sorry, let's do Tindo's question first.
That's Knit. Yeah.
Oh, is it?
Yeah.
Oh, that's right.
All right. So Knit wants us to do number 7.
Well, so that's also Knit's question, the ratio stuff that I put in the queue.
Okay.
So we can just ask Knit which they want first. Knit, what question do you want first?
We'll get to all of them. Knit, we're just going to do this one first. Yes, Prodvanix. Specifically because they said which answer highlights that number of hours in the equation. So we have to see it in the equation. Okay. We're going to do number 7.
Do you want to do it or you want me to do it?
I'll do it. I'm already up. Here we go. Make it big. Okay. The experiment confirmed their suspicions when the half of the lake containing the phosphates was teeming with blue-green algae. Our answers are was teeming, were teeming, are teeming, teams. 2 different concepts here. Number 1, subject-verb agreement. Was teeming and were teeming are both past progressive, but they're different subject-verb agreements. One of them is for plural nouns, the other one is for singular nouns. So we have to figure that out. And then are teeming and teams, that's present and also has to do with subject-verb agreement. So we have to find the subject regardless. Then we'll figure out if that answers the question fully or if we have to also figure out tense here. So the experiment confirmed their suspicions when the half of the lake containing the phosphates was teeming with blue-green algae. So what is the thing that was teeming with blue-green algae? What was it? Phosphates, because that's right before the verb. No, it's not. It doesn't always end up being the subject that is the word right before the verb. In this case, there is a long subject phrase, and there is one little nugget word inside that is the subject itself, the core, the kernel, the deepest nucleus. And that's what the verb has to match. So, when the half of the lake containing the phosphates was teeming. That's the whole phrase. Forget the word when, but it's the half of the lake containing the phosphates. So let's get rid of the things. Let's strip away until we find that exact word we're trying to match it with. Containing the phosphates. That's not what we need. That tells us something about the half of the lake that apparently is a little closer to the subject than containing the phosphates. So that's out of there. So we have the half of the lake was teeming. Okay? The half. Algae is the subject. No. Algae is not the subject. Algae is after the verb. So you can teem with something, like I'm teeming with excitement or something like that, but I'm the one that's teeming. It's not my excitement. Usually we have the subject before the verb, all right? So the thing that's teeming with the blue-green algae is the half of the lake. And the half of the lake is singular. I wouldn't say the half are here. I'd say the half is here. The half of the lake is here, okay? We want singular verbs here. So the half was teeming, sounds pretty good. The half were teeming, no. The half are teeming, no. The half teems with blue-green algae. Okay, now because the half of the lake is singular, you can also just replace it with the word it, which makes this a little simpler for your mind to process. So it was teeming, good, it were teeming, no. It are teeming, no. It teems, yes. A and D are both correctly conjugated for the subject, but we have past progressive and we have simple present tense. So we have to figure out now which tense is expected, and the only way to figure that out is to look around at the previous sentences to see when is this taking place. So I'm going to expose a little more of this. Close. Okay. Let's see. All right. Put it right there. All right. So I'm going to start at the top here. Okay. It's boom time says B because past tense. Yes, now A is also past tense. B is not correct for the subject. The subject is singular. The half of the lake is singular. So therefore we cannot say it were teeming. It is a singular subject pronoun. I meant A. Okay. Let's see. So we have, in one half of Lake 26, they added phosphates, nitrates, and a source of carbon. In the other, they added just nitrates, and a source of carbon was added. Maybe you have to delete that, I don't know. Schindler and Brunskill hypothesized that phosphates were responsible for the growth of cyanobacteria. Their experiment confirmed their suspicions when blah, blah, blah. This is all taking place in the past. We want a past verb, which is A. No change. Cookie God. You want shorter, simpler answers for the most part, yes. But in this place, this is verb tense and subject-verb agreement. Throw out, the difference between two words and one word is not a lot. You have to choose the right verb here. It's only when you have a lot of words and then very few words that you want to really think about, like, which one's shorter and simpler. But not in this case, because, I was swimming and I swam. You'd use them in slightly different contexts. Yes, they're both past, and one of them's only one word, but we have two tenses for a reason. It's shorter for redundancy. No, it's not. This is not redundant. This is verbs. Redundancy it's repeated information, or it's just being wordy. And that's not what this is. You cannot choose one word over two words because of redundancy. And especially for questions like this. This is verbs. Does that make sense? This is not a question to think about simplicity and redundancy, because verbs are verbs. Yeah. So this is going to be A. Everything's in the past. D is present. B and C are not conjugated correctly with a singular subject. Levi.
Yes?
You want to do the next one?
Yes.
Very good.
I think we got to hit a Koo's question.
Yeah, I think we do,
I
don't
don't know
we?
if we have then. We have no koozie questions.
You're right. Willie,
So we go to
have we done a what question? Yeah, we did. So let's go back to Willie now. All right. Do you want to do this one?
Which one?
This is a Willie question.
Is it the graph one?
Yes.
Uh,
Are you too comfortable? Come on.
yes.
Here.
I don't like these questions.
You want me to do it?
Don't know. Can
You
we do
do.
it together?
No.
Okay.
I know, but when you have a redundancy question, you pick the shorter one that doesn't take out important info. Yes, but this is not extra information or less information. Verbs are not. Verbs are verbs. If you have like, you know, the state where I grew up in is the state of Illinois, that's redundant. The state I grew up in is Illinois, which is true, by the way. Trivia about me. Okay, that's more redundancy. These, you cannot apply the shortest answer is best to every single question, because that's not what they're testing on every single question.
As a wise bird once told me. Also, something that I came up with totally on my own, nothing to do with Brady, is there's a hierarchy of importance here. You care about clarity most of all. So if you have the wrong verb tenses, things become unclear. Yes, you do always want to be concise, but what's more important than concision is clarity. If you change the verbs, it becomes confusing. That's not good. You need to be
Yes.
clear, you need to be specific, then you get to be concise.
Yes.
And a wise bird once told that to me. Well, once told me that. Adam, where'd you go? Okay. The 22 students in a health class conducted an experiment in which they recorded their pulse rates. Wow, in beats per minute. Whoa. Before and after completing a light exercise routine. The dot plots below display the results. Lovely, lovely. So beats per minute before exercise, beats per minute after exercise. Awesome. Now, let S1 and R1 be the standard deviation and range, respectively, of the data before the exercise. So we have standard deviation of this guy and the range of this guy. And then we have S1 and S2, or S2 and R2 being the standard deviation and range of this guy. Sure. Which of the following is true? Okay, so we're comparing the standard deviation of these two sets. We're also comparing the range of these two sets. Let's do the easier one. Range is way easier. What is standard deviation? I will tell you, Kuzi, after I tell you about alta ipsum. I'm just kidding. We'll probably do that later. Range is easier. So the range of the first data set, so R1 equals, well, it'll be 56 to 88, so the difference between those two is 32. So R1 equals 32. And then R2 is 80 to 112, so that is also 32. Which means that R1 equals R2. R1 equals R2. So does that get rid of anything? Yes, it does. It gets rid of B and C. B and C are both wrong. You probably figured that out, seeing as you chose A. And now we need to talk about the standard deviation. Yes, exactly. How spread out a thing is. So, and it's in relation to the average. Oh my gosh. The mean. Yeah, standard deviation is how close you are to the mean. So the top one, everything is clumped up. So the standard deviation is very small. If you have a couple data sets, 3, 3, 3, 3, 3. So that's this data set, and then we have another data set that's 1, 2, 3, 4, 5. These two have the same mean, right? The average of this is 3, the average of this is 3. But which one has, the word spread can get there, which one has more deviation from that mean? Well, this one doesn't deviate at all. Actually, the standard deviation of this first set is 0. You don't have to calculate standard deviation, but it's not a bad thing to know that if everything is the same number, then they don't deviate, so the standard deviation is 0. Then the average here is the same, but then we start getting numbers farther and farther apart. And then if we have, let's say, -1, 3 for good measure, and 5, 7, and 7, then the average is the same, but the standard deviation is even more than in the second one. So here, these guys, most of the stuff is right around what I would assume to be the mean. 72 is halfway between 56 and 88. That's where a bunch of the stuff is. Whereas in the second one, they're all spread out nice, pretty evenly, so there are lots of things that deviate from that central mean. Therefore, we don't know what the standard deviations are. We could calculate it, but we don't have to. Standard deviation here is, let's say S1 is small, it equals small, and S2 equals big, so therefore S2 must be greater than S1, which would give us not A, it would be, oh, it's just equal, not equal or equal, so D is the correct answer. Nick, does that make sense? No, this is Willie, this is Cookie God. Does that make sense? Does it make you happy? Does it cause you to get worried about things, get less worried about things, give up on things, repress and dissociate? What does it do to you? Yeah, that makes sense. Yeah, it better. I don't know what I'd do. Oh my goodness. That would have been super painful.
You know, I always think you're gonna go with "Kiss from a Rose" when you start singing that.
Yeah, I know that song, but I only saw the first couple.
I'm gonna slay you.
You're gonna slay me,
No,
Bert?
wait. What direction do you go with that song?
What song?
The song you're just humming.
Yeah?
What song is that?
Oh, Pirates of the Caribbean theme.
Oh, okay.
Yeah.
I get it.
Yeah, that actually wasn't a joke. That's what I was doing, Bird. So we have a what question now? Yes, we do. Ooh, this looks exciting. Oh boy, this looks kind of difficult. That's what it looks like. You two. My goodness. What does that say there? No, figure not drawn to scale. Who cares? All right, let's see if we can get this thing done. Khan Academy math is so irrelevant. I think it helps. Great, we got some healthy disagreement here. And based on Reddit, it helps. Okay, so here we have a large square, has side length of 320. Lovely. And the square is at an angle of theta from the vertical. Sure. Okay, so do we have theta? Yeah, we do have theta marked. That's pretty cool. And then we say that theta is, sine of theta is that, cosine of theta is that, and tan of theta is that. There are two dotted vertical segments. There are two dotted vertical line segments and two dotted horizontal line segments. Each dotted line segment coincides with a corner of the square. Sure. That's kind of interesting.
Yeah,
What is the side length L of the small square formed by the dotted line segments? Whoa. So, yeah, this is probably not crazy difficult. You probably would not see this on the SAT just because of the complicated nature of like how much stuff you have to understand in just the question itself. I would be very surprised if you saw something like this on the test. But my guess is that distance there that they label L is also going to be the distance of that little triangle up top that I'm gonna. All right, let's do the triangle on the bottom. That might help a little bit. So I'm just gonna take this portion of the triangle on the bottom here. So we have, here's the square going like that and like that, right? So this is a right angle. And then we have this dotted line coming up like that. Then we have another dotted line coming up like that. I'm gonna guess, because that length L would also be the length of that right there, correct? Because then we eventually have L up here. Oh, we can't even see that. Right, that's L. That's what they showed us up above. That's all we want, the distance between those two dotted lines. This is a square, so the distance between those two dotted lines is gonna be the same. We don't really care about that. Let's see if we can find this L. I think that's what we're looking for, right? we know sine, cosine, and tangent of theta. And that is this angle right here. Okay, so what I'm thinking, and we have a side length of 320. Who knows if that helps? It probably does. Very interesting. Yeah, this is very interesting. Okay. Eventually we're going to have, this goes back into the square, and this is a side length of 320, right? I think this is just a bunch of similar triangles. I think. We have a side length of 320. We have theta here. We need to find L. How do we find L? Well, if we know any of these angle measures here, when we have another side, we can figure it out. Can't you just do an inverse tan and get the sides of that part? Yes, you can. Yeah, I think what you're saying makes sense. Because to get this, I want to get, if I can get this distance, then we're good, right? Because then I can use this theta. Yeah, these are all similar triangles. This is a right angle here, and this is 90 minus, this angle here is 90 minus theta, so this must be theta there. 90 minus theta is the same thing as cosine theta. We do know that if this whole thing is 320, we can find, this is a bunch of work, which, Brady, do I want to do all this work or no?
I don't think I see it.
There might be a very quick way of doing this, but I honestly don't see it.
Okay.
So we're trying to find that length L.
Okay, the square's an angle of theta from the vertical.
Oh, we don't need this. No, that makes it too complicated. We could find that. We could have that angle.
Sine theta is that.
Oh yeah, that's, I guess not too bad.
Okay, there are two dotted vertical line segments and two dotted horizontal segments. Layers in the corner of the square. That's fine.
Right?
Side length L of the small square form of the dotted
It's a lot of work.
Rather than yours. Integer. Ha.
I want to just draw this whole thing. I'm gonna
Here, wait. So we know the. Yeah, we can do this.
Yeah, it's just kind of a lot of work. That's all.
Let's do it.
Okay. Fine.
No, definitely not. You want me to
Make it
open
not
up?
awful.
Here.
No, I don't need to see it. I just made this very bad.
Oh. Leviathan.
Yeah.
We can make this clear. It'd be awesome. Like a quick way to make this clear so that you could see what I see. Do you see what I see?
Ugh, this is so much work though. I just don't see this being on the SAT. I don't know if we want to spend so much time on this question.
Definitely don't either. So we could find that.
Yeah, there are.
trig. We could find
Ooh,
this.
I made this very
trig,
badly.
which is the same as that. Oh yeah.
Sorry
you know
about
what?
the-
No. There's an easier way to do this.
Yeah, it's not
bad.
not bad. It's just I don't want to do all.
No. We can. It's not going to take that long.
Okay.
It's not going to take that long.
Fine.
Okay.
This was too much. This doesn't need to happen.
Okay. Jeez.
So if we want L, which is there.
Okay. So let's just start.
So we have 320.
So this angle, let's just find this right here with trig.
Yeah.
Okay, so we know that's going to be
I'll do this on my phone.
tan. So tan
tan
theta
inverse.
equals x over 320.
Yeah.
So they gave us values to use, so I'm assuming they want us to use those values. So,
I'm gonna have to get my computer.
okay. And they told us what tan to use.
Yeah.
Wow, this is tiny. Let me blow this up. Okay, so tan theta is 0.64. So x is going to be 320 times 0.64.
320 times 0.64.
Yeah.
204.8.
204.8. Okay.
You got it?
Yes. Awesome.
What is next, sir?
Okay, let's calculate this length right here. I see. I think I see where this is going. So the hypotenuse of this right triangle. So we have 320 and 204.8 are the side lengths.
Which one? So what are we doing?
204. We're finding this length here. So hypotenuse.
Okay. So 204.8 squared
Very different.
plus 320 squared.
Yeah.
Uh, 380 roughly.
380.
Yeah.
Okay, so I'm just going to redraw that triangle over here. All right, so this is 380, this is 204.8, and this is 320. So the area of this triangle, if we choose to look at it like this, base times height, would be 1/2 320 times 204.8.
Wait, why are you finding the area?
You'll see.
Sorry, say that one more time.
We have 1/2 times 320 times 204.8.
Okay, 320 times 304? 204.
Yeah.
Uh, 32,768.
Okay. Knowing that that's the area, we can find the length of this line because we can choose to treat this as the base.
That's kind of fun.
Yeah. So 1/2. So we choose. Let's call this x. So 1/2 times x times 380 should be set equal to the area that we just got. So we have to double that and then divide by 380,
So,
or just 150 plus 40 is 190. So take the number you got for the area and divide by 190.
172.5
Okay,
ish. We're rounding a lot.
that's fine. 172.5. No, not koozie. This is never going to show up. Don't worry. Okay, so this distance right here from here to here is 172.5. You said 172.5. All of these dotted lines are the same length. All of them are from a corner of the square to the other side, directly. So this entire length here is going to be what we got before, which is the hypotenuse. These are all hypotenuses of looking at the square from a certain angle. So all these are 380. So what we need to do is just figure out what this distance would be right here, so we can subtract that away. Okay, so if that's 172.5, this right here, oh, okay, yeah. This right here is also 172.5, but we need to figure out the length of this whole thing.
I feel like that's not super useful.
Well, if we're gonna find this length here, knowing this,
Yeah, we should find the other side.
right, which is the hypotenuse of here. This whole thing is 380, minus that, minus whatever that is. So what is this a part of?
It's the same thing as the bottom. I just don't think it matters.
Well, that's not the right attitude. 172 and 204. We don't know that part.
Bird.
If this right here, yeah, okay, hold on. This is also going to be 204.8, and this theta right here is the same as that theta right there. So we can find this side length because it's the opposite of that theta, and we know the hypotenuse.
Yeah.
And then once we have that, so, I mean, we're right there. Let's finish it. Sine theta is equal to S over 204.8. So S is equal to, the sine theta they wanted us to use was 0.54. So 0.54 times 204.8. You got that, Levi?
No. What?
0.54 times 204.8.
0.54 times 204.8 is 110.59.
Okay, we're right there. So subtract. Ready?
Yeah.
380
380.
minus
Yes.
172.5 minus 110.59.
96.91.
96.91. Do we have the answers for this?
Don't know. There was a bunch of rounding. So that's, I don't know what the rounding is expecting.
They did give us values for sine and cosine that were rounded. Yeah, do they give you the answers for this one? That's the best that we can do. Yeah, this is, someone tells me the right answer, El Mao. Tindo. Someone tells me the right answer, El Mao. What do you mean by that? Prodvanix isn't here anymore. Oh. All right, well, we're done with this one then. Okay, what's the next one? Who's got the next question, Levi? Like, is it back to Cookie?
Sure.
Okay. So it's going to be this one right here. Okay. In the equation above, which of the following is a possible value of x plus 1? And we have x plus 1 is equal to 2 over x plus 1. Okay, well, considering that those two things, x plus 1, are the same in both of those places in the equation, let's just relabel them as y. Let's just relabel them as y. We don't need to solve for x, because it's not asking to solve for x. It's asking what's one possible value of x plus 1, which incidentally is the same thing as what's on the left side of the equation and what's under the denominator on the right side of the equation. So if I set this up instead as y is equal to 2 over y, then this thing is going to be a lot easier to solve. Because this stands in for x plus 1, this stands in for x plus 1. They're asking us to solve for x plus 1. So just to cover my tracks here, let me set y equal to x plus 1. So if I just solve this thing for y, I'd multiply both sides by y. I'd get y squared is equal to 2. So y is going to be plus or minus the square root of 2. And that is going to be b right there. So this is actually easier than it looks. If you try to solve this for x, you are doing more work than you have to do. Brady quick math. Yo, what? Does that make sense, Cookie God? That's nuts. It is nuts. It's nuts. Lightly salted. Good. All right, we can keep going then. Who's got the next one? Levi.
Yeah.
You haven't done this one yet, right? You did a different histogram one, but I don't think you did this one. Not that you are going to do this one. Like, I'll do this one if you don't want to.
I don't wanna.
You want me to do it?
Yeah.
All right, I can do it.
I don't like histograms.
There you go. Okay.
What do you want, Kuzi?
Let's Get this one going. Oh, geez. You guys and your... I don't know what you're talking about. Okay. That's too small for me to read. I'm going to read out the computer. Both dot plots to the left show the years in which various New Zealand wineries were founded. The first dot plot rounds these values to the nearest 10 years. I'm going to read this normally. And the second dot plot rounds these values to the nearest 20 years. If we calculate the mean, median, and range based on each of the dot plots and not from the original data used to generate them, which of them will differ from the first dot plot to the second? Oh, this is super interesting. So basically, they compressed the data. They had buckets for every 10 years on this histogram, and then they made those buckets instead encompass every 20 years for this histogram. So it looks like, for instance, for 1880, 1880 is composed of the number for 1870 and 1880. So they group that into the new 1880 category, whereas 1860 still has just the one from 1860. So 1900 still has the 3 it had. 1920 now has, it looks like, 2 from 1920 and 1 from 1930. And then the rest of the 1930. So what this is probably doing is cutting off the decades in half. You probably have, if 1880 is the center, then you probably have 1870 to 1890. So that's probably that category right there. I'm going to put that from here to here. We have 70 to 90. And then the next one will be 1890 to 1910. So that's how they're creating these buckets. Anyway, which of the following is going to be different? Okay, so we have none will differ, the mean only, the mean and median only, or the mean, median, and range. Looking at this data here, we don't get specifics. All we get are how many wineries were in each year. So we have one winery in 1860, one winery in 1870, one winery in 1880. Okay, so they're asking, yeah. So here's what the actual numbers would look like according to this. You'd have 1880. The next data point would be 1860. Jeez. 1860 plus 1870 plus 1880. And then it'd be plus 3 times 1900. And so on and so forth. So every winery would be associated with a year, and that would be its data point. The reason why I'm adding them is if you're going to take like the mean, you'd add all these up and divide by the number of wineries, and you get the average year that they're founded. So the range, we're going to start with that. The range is simply the highest value minus the lowest value. The highest value in both lists is 1980. The lowest value in both lists is 1860. So that range of years is going to be the same in both cases. The range will not change. They're asking which one is going to be different. Yes, so D is going to be wrong because the range will not change. Always remember that. In any context, the range will not change. Don't remember that. I'm kidding. It's only for this one. Okay, so then let's look at... This data is less specific than that data. So if we try to find... It looks like we have the mean and median to figure out as well. We try to find the median here. There's the same number of dots in both cases. So the median is where you start crossing out dots on the left and right until you get to the middle dot. And how many do we have here? It doesn't tell us how many that we have here. Okay, that's okay. We could count them, but I don't feel like doing that. The median, the problem is you've got these buckets that are changing. You've got a bucket like up here. Let's look at 1900. So the 1900 bucket would be from 18... we do that. The 1900 bucket is from 1895 to 1905 because 1900 is the center of the bucket, and all of these buckets are 10 years wide. So if you're going to label a bucket 1900, it doesn't make sense to make that 1900 to 1910 because then you have 1910 on the next bar. So it's got to be 10 years with 1900 as the center. And then we have this new list down there that's 1900. And 1900 is going to be anywhere from 1890 to 1910. 1890 to 1910. And if you don't have the original data, the way that you'd read this is I would write, we have 1860, We've got 1880, 1880. And look at what's already happened. I didn't count one of these as 1870, even though one of these happened in 1870. So we're going to have fundamentally a different set of numbers here, which means that our mean will change if we have different numbers. We have the same number of numbers, but we add all these up. If they're different numbers to start with, then they're going to be different. And our median's also going to change because we have different numbers. Again, the dot that we pick will be the same middle dot. It'll represent the same winery. But because these will all be spread out in different buckets now, we won't be able to tell what the original years were. Like the dot that's at 1860, it wasn't founded in 1860. It might have been. We don't know. There's a whole range of years it could be founded in, but they put it in the 1860 bucket. So just looking at this data, that's all we can conclude. We don't know the actual year it's from, just the categories of years that they give us. That is why everything will change. Everything is about to change. All of it. Okay. We got Ned. Levi, you're up. What are they asking here? I assume they're asking you to solve for x.
I don't know, sir. Kuzi, I don't mean to be a lazy bum. Can I erase this?
Yeah.
Oh, baby. I love questions like this because they're not dot plots.
You hate dot plots.
I do.
Wasn't your great-grandfather a dot plot?
Yep.
So how do you hate dot? You just hate him?
Well, I loved him, but then he went off to war, and when he came back,
He was different?
things were different.
Yeah. He probably killed a lot of men.
A lot of dots.
Maybe.
Okay, can you make this bigger?
Was it the famous dot war of 1795?
Yes.
He abused Levi. That's probably what it is.
Yeah.
Mm.
I was a dot when I was very young. We should do this Tinder thing.
Tinder.
Yeah. Oh, yeah. Okay, so we got this stuff over here. We're solving for x? Or what are we doing?
Yeah.
Does this question come with any context?
No.
No, it's just this. Yes.
We can do some stuff here.
I haven't really looked at it. So we have theta. We have 8 rad 2. Can we? I don't really think we can. Not this hard.
In terms of
Sure.
In terms of theta, that wouldn't get us anywhere. I guess that'd be 90 minus theta, and the cosine of that is the sine of that.
Yeah, I'm not.
We can do that.
What are we doing? Am I finding x in terms of theta or theta in terms of x?
I think we have to find x in terms of theta, but I think there's a way to actually solve for x here. Because we're going to be using sine in one case, and we're going to be using cosine in the other, but cosine is going to be 90 minus theta.
No, but we don't know what the length of that thing is. Because the top triangle isn't, like, what type of triangle is it? We don't know the measure of theta, so we can't possibly find out any other values of that triangle.
Well, hold on. I think we can, though. So if we take sine of theta.
So if we have that, I mean, this could be like that, but it could also be like that. And this could be like that, but it could also be...
We have a right angle. It couldn't be like that, because we have a right angle on
Oh.
So if we look at that...
True. I didn't see that one.
Sine of theta would be 4 root 2 over x. You solve this for x, you get x is equal to 4 root 2 over sine theta. And if we solve for x in the other equation, that bottom right angle is going to be 90 minus theta. And there's a trig identity we can use with that. So they tell us that this is theta, but because this makes a right angle, this is going to be 90 minus theta. And so that's our angle right there, 90 minus theta. And the cosine of that angle would be x over 8 root 2. So we solve that for x. We have x is equal to 8 root 2 times cosine of 90 minus theta.
Nice.
And then we're going to set those equal to each other.
That's
But
fun.
there is...
I think that's just gonna be. What are you setting equal to each other?
x.
So you're solving for theta in terms of x.
This would give us theta. Yeah.
Well, no, but no, what you've just written here is an identity.
Right. We can use that to put sine theta right here.
Okay.
Or we can solve these both for sine theta. You're right. Okay, so cosine of 90 minus theta is sine theta.
Mm-hmm.
So yeah, you're right. If we want to solve this for x right off the bat, we have to solve both these for sine theta. So forget I did this step right here. Now we have these both sine theta.
Mm-hmm.
I should have done it right here, shouldn't I? I did all these steps. Here. So we set these two things equal to each other. So 4 root 2 over x is equal to x over 8 root 2. And then we're going to cross multiply and solve that.
Cool. So that, you want me to finish it?
Sure.
Let's do blue. So we get 32 times 2 equals x squared, so 64 equals x squared, so x equals 8.
This thing right here is the crucial part. Otherwise, like, it turns out you don't need to know what theta is. No matter what theta is, the sines and cosines are going to kind of cancel each other out in a certain way. Who asked this question?
I don't know. I'm trying to think if there's a faster way, if there's a fast way to prove that ABC is a 45, 45, 90 triangle.
Because it ended up being a 45, 45, 90 triangle.
Yeah.
They're both right angles. I mean, they're both right triangles. And so is the smaller one. The smaller one is also a 45, 45, 90 triangle.
Yeah.
How would you prove that?
I don't know.
Not because he says it's a rectangle missing a triangle.
Yes, but that's assuming that, well, yes, that's true, but we don't know if if we know the left triangle that's not drawn in is the same as the right triangle, then that would show that it's an isosceles triangle to ABC. But is it because 4 square root of 2 is half of... Yeah, I mean, that's true, but that's like doing that work anyway.
So, they are similar triangles, aren't they? I mean, yes, they are. This bottom bigger triangle has 90 minus theta, which means this other side A has to be theta itself.
What? Yes. So you have thetas there and there.
So that is theta. This is 90 minus theta. And then this
and then
triangle,
you have this other triangle that's got a theta here.
and a 90 minus theta up there.
And so if this is 4 rad 2, and then this is, can you write an 8 rad 2 here? And if this, let's do it in pink, is x, then we have...
This is half.
Yeah, but I don't necessarily... So if we have sine of theta equals x over 8 rad 2, we have sine of this theta equals 4 rad 2 over x.
I mean, we just proved
Which is
that
what we said.
we've just proven they're similar triangles. So I think at this point, we could make a but we don't know that they're isosceles.
Yeah, that's what we're trying to show. If they're isosceles, then we're done.
This is half of this side. Oh, I think okay. If this is half and you bring it right down, it cuts this in half, which means that has to be 45.
How do you know it cuts it in half?
If it bisects the bottom side of this,
So
it
how-
has to bisect the angle that
How do you
opens
know
up to it.
bisects the bottom side?
It's half of this.
How do you know that?
4 root 2, 8 root 2.
Oh, I see. Yeah. Yeah, that makes sense. So then we just have a square.
That's 45. This has to be 45, and then all of it turns to 45.
Yes, there you go. Nice. That makes sense to me. So anything is 4 over x, and then it also equals. Yeah.
What time is it?
That's fun. I'm so tired. Dang.
34. We gotta
Yeah.
go.
We have to go. We have places to be.
Alt
And so do
Ipsum.
you. Alt Ipsum. It's not here, but it still does the same stuff.
It's in here. That's
Yep.
where Alt Ipsum is. That's
Yes.
where it will always be.
And so when you're studying and when you got to do stuff, you gotta
Alt Ipsum.
Alt Ipsum it up. We are nerdish.
Well, we can't say it until it's ready.
Yeah, I want to just so.
There it is.
Alt Ipsum. Yeah, it's free for a month.
You know what else is free for a month? Breathing.
And that months come for free.
Yes, they do. They just don't stop.
You just pay them in time and wrinkles.
Wrinkler.
Wrinkle.
Very good.
Have a lovely night, everybody. Is the wood glue free for a month?
Wood glue's free
No.
forever. That's why he said no, because that's not true. It's free forever.
Yeah, it's not free for a month.
Wood glue actually reproduces asexually, so it just spawns more wood glue.
Yes.
Yep. And you don't even need to feed it anything. Like, it's the one organism that just somehow creates itself and
That
more
was
and more
disgusting.
mass. Well, that's what wood glue does. It's gross. Yeah, more mass comes out of nowhere. It's the one thing that violates
Yeah.
the conservation of mass.
And anything like that sands very easily
Yeah.
with a short clamp time and water cleanup.
Didn't your great-grandfather have a short clamp time?
Yes, because all dot products have a dot product.
Dot product.
Dot product.
Dot product.
Dot Van Eycks and koozies stuck together in disguise.
With a trench coat. So it only looks like it's Bogdanix.
We are
Night.